Video is going to look at global winds. So these are winds that blow for longer distances over the entire world, unlike local winds which just blow for short distances and are due to local heating. So we'll talk about the causes of global winds, we'll look at the main types of global winds and see how they are affected by the Earth's rotation. So first up, what are global winds? These are winds that blow steadily over long distances. Right? They're caused by unequal heating, just like local winds are. And basically what happens is the Earth heats up more at the equator than at the poles because we get more intense sunlight at the equator. This creates a low pressure system here. Remember, higher temperature, lower pressure. And so we have a low pressure system setting up here and a higher pressure area setting up here. All right, so the pressures are going to want to balance out. However, it doesn't go quite that simply. All right, so if the Earth didn't spin, winds would just blow straight from the poles, cold, high pressure, to the equator, warm, low pressure. All right, so the Earth was just sitting still, but the sun was still shining on it. You would have steady winds blowing from the poles to the equator. You would have high pressure here, low pressure here, and you would get one big convection current going all the way from the pole to the equator and back. However, the Earth is rotating under that moving air. So if you can think about a balloon or the Earth having that layer of air above it, but the Earth can rotate under the air. So the air almost gets kind of left behind as that Earth rotates. So as the Earth rotates under the moving air, it causes the winds to curve off to the side. And we'll do a little demo with this in class tomorrow. All right, but as this wind is trying to blow towards the equator, the Earth is moving rightwards underneath it, and that causes the wind to bend off to the left. All right, in the other hemisphere, the opposite happens. All right, so this curving is called the Coriolis effect. All right, and that's going to be our next main idea. All right, and it's important to know which way winds curve in different hemispheres. All right, in the northern hemisphere, winds are going to curve to the right of their direction of travel. Right, this wind that's trying to head north curves off to its right. This wind heads off to its right. So it seems a little backwards to us. If you really want to, you can just kind of flip your computer around until this is pointing straight up, and you can see that this wind is curving to its right. In the southern hemisphere, south of the equator, winds curve to their left. You can see that happening there. Alright, so now that we've added the Coriolis effect in theory, we should have winds just going straight from the poles to the equator, but bending off to the side as they go. Bending off to the side as they go. But it turns out that the Earth is too big for that long distance wind to get set up. And so the unequal heating coupled with the Earth's rotation ends up setting up 6 wind belts around the Earth. So these are areas with very predictable wind patterns, right? And we've got a couple of them that we need to know. Fortunately, they're mirrors of each other. So the northern hemisphere is a mirror of the winds in the southern hemisphere. Right? So you really have 3 sets of wind belts in each hemisphere, but they're the same in each. All right? Let's start with the wind belts, and I'll come back to the common areas. The first wind belts we have are what are called the trade winds. These are easterly winds. Right? And you're going to want to get a quick description of each of these in your notes. Trade winds are easterly winds. Right? They go from 0 to 30 degrees, 0 being the equator, 30 being 30 degrees north or 30 degrees south. So either way, these are easterly winds. From 30 to 60, we have prevailing westerlies. Right? These winds are blowing in general from the equator back up to the pole, and they're getting curved to the east. Right? So we call them westerlies because we name a wind for where it's from. And then lastly, we have polar easterlies. These head from either the North Pole or the South Pole towards the equator, and they get bent to the west, so we call them polar easterlies. Right? Where these meet, we get areas of either high or low pressure, but we have very little wind. Right? So you can see on the left over here, these arrows are showing how air is moving up and around through the atmosphere. So these arrows on the Earth show surface winds. These arrows show as the air moves away from the Earth's surface. So at the equator, air moves up and then heads either north or south towards the poles. Right? And at the equator, we have an area called the doldrums. So instead of moving side to side here, wind is moving up, and so we get very calm areas. At 30 degrees north and 30 degrees south, you can see we have two sets of colder wind pushing down towards the Earth's surface. Right? This is a higher pressure area. Again, not much side-to-side movement. These are called the horse latitudes. Right? There are other calm areas at 60 degrees, but they don't have a particular name. These names were named by sailors originally, and there's not a whole lot of sailing activity that goes on that far north or that far south. So we would just call that a calm area at 60 degrees north. All right, make sure you put 3 questions at the bottom of your notes. I'm sure you've got a couple. We'll do a couple different activities with this in class tomorrow to kind of clarify these wind belts and see why the winds have to curve the way they do.